Welcome, everyone, to a special interview episode of This Week in Science. This is TWIS, This Week in Science interview with Matthew Cobb, recorded on Wednesday, November 10th, 2022. Thanks to our amazing Patreon sponsors for their generous support of TWIS. You can become a part of the Patreon community at patreon.com/thisweekinscience. Happy Day of Science, everyone, and we are so glad to have you here on the show, joining us from where you are. Welcome to this week's special interview episode, and we definitely have a great show ahead. Before we jump in, I do want to remind everyone that if you are not yet subscribed to This Week in Science, you can find us all places that podcasts are found. Look for This Week in Science. We also stream live weekly Wednesdays at 8 p.m. Pacific time and on occasional Thursdays and Fridays at 11 a.m. Pacific time for interviews. And you can find us on YouTube, Twitch, and Facebook. We are TWIS Science on Twitch, Twitter, and Instagram. And if all this is just too much information for you to hold in your brain for one working moment, just go to twis.org. Twis.org is our website. But now it's time for me to introduce our guest, who is Professor Matthew Cobb, a British zoologist and professor of zoology at the University of Manchester. He's spent many years studying psychology, animal communication, pheromones, scent. He's also written several popular science books, including the latest, which is being published here in the United States as Gods, A Moral History of the Genetic Age, which comes out in print on November 15th. Professor Cobb, welcome to This Week in Science. Thank you for joining me.
Thank you very much, Kiki. It's great to be here.
It's so wonderful to get you to talk about some fun things. I mean, as Gods, the moral history of the genetic age, it really gets at the point that we're bringing together science and history. And from our learnings of the past, potentially we can go into the future more intelligently. When did you first come to your interest in science history and looking back at history?
Well, I've always been interested in history. I did it in the UK. You have a very restrictive system of education at high school level. But I was unusual in that instead of just doing sciences or just humanities, I did a mixture of the two, much to the despair of my teachers. But that actually was a great help for me when I became a student, then eventually became a scientist, because it meant that I was always trying to understand not simply the way things are, the way that we study things or understand them, but also how they got there, what have been the kind of differences in the past. And then that was a kind of general interest. And then in the mid-90s, I was working in France at the time and was working on a big review. One of the things that scientists have to do is write lots of, you read everything there has been ever written on your tiny little topic. My tiny little topic was the maggot's nose. And I kept on seeing these references to material from the 17th century. And I couldn't believe that it would be very interesting. And I went into the library of the National History Museum, which was just down the road. And I found one of these books and thought, God, this is astonishing. And that got me interested really in starting to do quite a bit of historical research, first in the 17th century, and then more recently in the 20th century history. And as you indicate, also perhaps 21st century futurology.
Where we're going to, yeah. And it's interesting that you bring up 17th century scientific work on the maggot. I mean, infections and maggots were probably very important back then, but it was really the 16th and 17th century that the scientific revolution was getting started. And additionally, intelligent writers were starting to write on fictional topics, and Mary Shelley wrote Frankenstein's monster, which dovetails very neatly with the kind of the timeline that we're looking at. Having worked in genetics and, modified genes in fruit flies and these laboratory standard research organisms, our model organisms, have you ever throughout your career considered the aspects of Frankenstein and the modification that science has started doing more and more, or is it more recently that these kinds of questions have started coming to the forefront?
Well, no, I think, I mean, so people have been studying, I've been studying Drosophila, this tiny little fruit fly, uh, for nearly 50 years now, 45
Yeah.
years. So it's a long time. Um, and one of the main ways that we have of trying to understand how it works, how the genes work, how everything about it works, is by changing its genes, creating mutations. And I think right from the very outset, when I was studying flies with different colored eyes or whatever, you always wondered, well, what's going to happen if one of these flies gets out? If it gets out of the laboratory, what is going to be the consequence? Now, the answer fairly obviously is, well, these mutants aren't that healthy, so they're going to die. They're not going to survive, and the gene will just disappear.
Right.
But around the same time as I was moving into this field as a young student, that was exactly the same time that genetic engineering was taking off. And there were great concerns there, not about insects because we couldn't manipulate them at the time, but it was all about microbes and viruses. And I was aware from the very outset about these debates that were taking place when I was a student and a graduate student, meetings, organizations, protests all over the world, as the people were worried by what the scientists were doing. And to their great credit, the scientists were worried as well. And that's one of the kind of themes of the book, is that genetics, which is, this is, I mean, it is a moral history, this book, the subtitle. Really, it should be titled, but you couldn't call it that in a popular trade book. It's a critical history. But if we said it was a critical history, people wouldn't understand what it meant. They'd think it was going, nah, nah, nah. And it's much more actually reflecting on what that history has involved and trying to understand it. Because 4 times in the history of genetics, the scientists have become so frightened and so alarmed by what they've done that they've decided to have a research moratorium, a pause, a moment, a period, perhaps several months, in which they will not carry out those experiments. And I was struck by the fact that that's unique. So geneticists know about this and are very proud of it because it shows they're kind of socially responsible. But there's no other example of science, not even in the people who are developing the nuclear bomb during the Manhattan Project in the Second World War. Nobody in any other field, as far as I'm aware, no other group of scientists has said, look, this is a bit alarming. We should stop doing this until we're really sure that it can be done safely. So that's what I wanted to explore. I wanted to explore that history, which is kind of, I've traced, I've gone in lockstep with. I've grown up and been a scientist and an academic at the same time as this field has repeatedly raised doubts, concerns, nightmares, and then they've kind of faded away. And there are 3 in particular new things on the horizon that I'm very worried about, and we can talk about them in a minute. But the principle is that I knew that the things I'm scared about now are similar to the things people were scared about, say, 50 years ago. And those worries turned out to be, not to be irrelevant, but they weren't as acute. The danger wasn't as acute as people thought. So I wanted to find out, am I overreacting? Is this me being scared of that, or is it really an issue? And so what better way to do that than to write a book, find out, give myself lots of time to read and think and talk to people.
I think that's fabulous. It's an opportunity for you to actually get an answer for yourself as opposed to.
Absolutely. Yeah. I didn't know where I was going. I mean, I knew the kind of story I was going to tell. I didn't know what the answer would be by the end.
There are a couple of reviews out that have said that you take it as you said, it's a critical look, but that say it seems as though you're negative about the outlook for scientists to manage themselves. Do you think that those are accurate? That saying that you've taken a negative stance is where you ended up?
I think this is too important to be left to the scientists. That's the key thing. I don't think that we should. So the first of these, the first 2 really of these moratoriums took place in 1972 and then 1975. And this big meeting took place at Asilomar on the
Yeah.
California coast, which is very famous amongst geneticists, perhaps not amongst the general public. And about 200 scientists from all over the world came together, and they discussed how these experiments on what was called at the time recombinant DNA could be done safely without risk of causing, strange pandemics or whatever. And what's very striking about that is that not only did they not ask, is this the right thing to do? They just thought, how can we do it safely? So the discussion was all about safety, but also this was entirely kind of informal. It was entirely up to the scientists themselves. And although they argued that the NIH, which is the main funder of genetic research in the US, the main federal funder, should not should make it a condition of funding that people obeyed these biosecurity protocols. It didn't have the force of law. There was no if you had private means, as some companies did, you could do what you want, which is still the case in many respects in the USA. So I was very struck that there were in this moment where there was self-regulation. The scientists decided it's okay, we can do this safely. Don't worry your little heads about it.
Your little
it wasn't
heads.
quite as bad.
No.
It wasn't really like that, but it was a bit of condescension in there because the public wasn't involved. They did have journalists there, but there was the voices of the many people who were worried about those experiments were not heard. They were not present. And I think that's really quite striking, that this key moment, which is praised understandably because it enabled an awful lot of development, both in industry with the development of the biotech industry, but also a lot of very important scientific and ultimately medical research. The public wasn't anywhere there. And that meant that after the meeting had happened and after these experiments began, there was an awful lot of public disquiet. And for about 5 years, there were a lot of protests, there were meetings, town hall meetings, in particular in Cambridge, Massachusetts, over Harvard's plan to build a new lab. And then by the end of this period of huge debate, around about 1980, the whole thing just kind of evaporated because it turned out for various reasons that the experiments were safe. Not only were they safe in the conditions that they were being done, but some experiments that people were worried about, say, putting a human gene into a bacterium, what would happen then? Turned out the answer would be nothing, because the bacterium wouldn't know what to do about the human gene, because our genes have special kind of regulatory stuff on them that bacteria don't understand. And above all, you could make a lot of money.
Yeah.
So
money as above all else.
Yeah, you've got to remember this is 1980. So this is Reagan. This is the beginning of the Reagan years, deregulation. Yeah. And it's also the moment when both Genentech and Apple went public. First Genentech, the big biotech company, and they were actually incorporated the same week in Silicon Valley. I was quite amazed. It's quite a coincidence that I mean, obviously they didn't know you. Steve Jobs and Steve Wozniak and the founders of Genentech didn't know about each other, but it shows you part of that spirit of what was going on in that part of California. And so then, I thought all this was this fascinating kind of mixture of science, politics, culture, economics, and so on.
It is. And, in the decisions that we make and the things that we do go on to impact the future. And so these companies have Apple and Genentech, and since then many others have gone on to just incredibly impact everyday human life to the point now where, when it comes to genetic modification, where we have people who are still concerned about genetic modification of organisms. Here in the Pacific Northwest, we have Franken salmon, as some activists are calling it, but we've got salmon who have genes that affect their longevity and their ability to reproduce. And there are many organisms that we eat. And so genetic modification itself is a part of our lives. And in the book, you go through all sorts of various technologies and different methods of modification that we've used. But then one of the instances that we've gotten to in recent history that led to a brief moratorium, and one of those moments that people, scientists, sat back and said, let's take a break. What are we doing here? Was with CRISPR, the
Yeah.
uh, the technology that has allowed Chinese scientists to modify human genes in
Yeah.
human embryos.
Yeah, I mean, this is the most disturbing, I think, thing that has happened recently. And it's disturbing not just because what happened. So in 2018, a Chinese scientist called He Jiankui, he changed the genes of two, what at the time were single cells embryos. So these were fertilized embryos. Now they are little girls. In fact, there were three, we now know. And this experiment was really botched. It went horribly wrong. Lots of we don't know much about what the exactly what he did, because the
Yeah.
information that's come out of China has been very little. But the key thing is that this was a very, very bad experiment which went horribly wrong. With a bit of luck, the girls will be well. We don't know, but they have mutations that we have never seen in any other human, and also not all their cells are affected. And normally, all your cells have the same genes. So that could be bad for their future well-being. Plus, the mutations that have been introduced are going to, if they have children, they're going to be there. I mean, a gene mutation is forever.
And isn't
Um,
that and that's one of the crucial points in the debate about human genetic modification.
yeah,
It's one thing to impact your own genes related to a disease that you're suffering from within your own lifetime. But if you are impacting those cells that go on to
yeah,
allow for reproduction, that's impacting the future of humanity because then those genes can spread.
yeah, and it's also obviously you are. I mean, if you think about it, it's a really kind of operationalist, rather unpleasant view of human life. I mean, those girls didn't ask to have their genes changed.
No,
Somebody did it to them.
right.
Which is going to be, I mean, so there's a lot of people get very, I'm not going to mention his name, but there's a certain person who's currently wrecking a bird social media program that he's very keen on, he
Yeah.
says, you're going to go to Mars. I'll take you to Mars for free. And then you can work on my, in my slave colony and pay off
Yeah.
your,
Your debt, your travel
pay
debt.
off
Yeah.
your travel debt. And maybe we can also
Yeah.
mutate people so they can live on Mars quite happily. And just think about, well, wait a minute, those people, if you could do that and you couldn't, they'd just die. They have been turned into this other thing. No, they never asked that. They never asked
Yeah.
for that. They had no choice about it. They have no choice. And I think everything about that experiment in China stank. There was no medical need. It went wrong. But above all, the scientific community at the time was, although it was outraged when it heard what had happened, was complicit in this atmosphere of
Yeah.
that the world was on what they called a prudent path to the use of genetic engineering, allegedly in human embryos, allegedly to get rid of genetic diseases.
Yeah.
But as now everybody has recognized, I'm glad to say, in fact, in the vast majority of cases, overwhelming majority of cases, couples with genetic diseases who wish to have an unaffected biological child can do so through existing techniques without changing their genes. You select embryos, go through IVF, and you select embryos that are unaffected. And the number of couples around the world who wish to have a child and cannot have it safely by that means are probably a few hundred. So really, that's outside of the tech bro fantasies of living on Mars. That is really what you're talking about. You're talking about meeting the desires to have their own biological child of a few hundred couples around the world. And we know where those couples are going to be. They're not going to be randomly distributed. The only people who
No.
are going to have access to this technology are going to be in the West, in particular, very wealthy individuals. So I think there's a million and one reasons why this is a bad idea. And I think the key phrase, Fyodor Urnov, who's a genetic engineer who works on somatic gene therapy. So that's therapy which will not be transmitted to the next generation. And he's been right from the outset virulently opposed to this as this embryo editing. He said that human embryo editing is a solution in search of an answer. Sorry, is an answer
Answer in
in
search of
search of
a
a
solution.
question. There
A
we go.
question. Yep.
I got
We'll
there in the
get
end.
that phrase right.
An answer in search of a question, which is,
Yeah.
a very sharp way of putting it. There's no reason why we should do this. It can go horribly wrong. There are immense ethical issues, including those, as I say, about the children, and their own sense of being and and personhood. Obviously, no child has to be born. We're all a product of chance, but at least we're all equally a product of chance, and it's all a bit weird. Whereas some of us might be manipulated in order to produce particular outcomes that certain individuals might desire, not us, but somebody else. And I think that's very bad.
Yeah, going back a little bit also to the allusion to certain individuals with certain ideas for humanity. There is a group who are calling themselves long termers, or they're into long termism. There are also um, effective altruists, individuals within the technology community who are looking at the future of humanity and what they can do in a very, very, very long term to ensure the survival of humanity.
Yeah.
And they're willing to get there at whatever cost to current humanity. So future humanity is more important or more valuable than current humanity, as long as we get
Well,
to
it's not only
future
humanity;
humanity.
it's the whole
Yeah,
planet. I mean,
the whole planet.
I
Yeah. It's
yeah,
so the
I
whole
admire the
moral
work of
ethical
yeah,
conundrum is this is a huge philosophical question,
yeah.
right?
I admire the work of some of these individuals, who are mainly men. It's quite interesting.
Yes.
But you know, okay, yes, we need to ensure the long-term survival of humanity, but that's not by fiddling around with genes. That's going to be by sorting out the climate and resolving the problems we have of carbon economies around the world, which we're all part of. I mean, there is
Yeah.
no country is not involved in that. We're all completely imbued in it, and that is where the intelligence and the brilliance and the initiative and the vision and the money of these people should be directed. Because without that, we're all, not just us, but
Yeah.
every organism is going to be sunk by this.
Yeah. The outcome of the moratorium, based on the human embryo genetic modification of
Well, there's not
HRT.
actually
Um,
this is part of the
yeah.
tragedy. There's no moratorium.
That,
The scientific community, not absolutely, because the
but,
scientific community did not agree on that one. And
okay. Yeah.
strikingly,
Yeah.
Jennifer Doudna and Emmanuel Charpentier, the two inventors of CRISPR, they differed. Charpentier signed the call for a moratorium, and Doudna wouldn't. So, she's not engaged in that kind of research, but her view is, look, it's too late. We can't stop it. I think that's wrong.
Hmm.
With all due respect to somebody who's a lot smarter, done much more for things, genetics and probably humanity than I will ever do. But I think
Yeah.
she's wrong on that. And the shift that there has been in after the Herjonki scandal erupted, there was a very slow move as people really thought hard, which they should have done before. Why do we want to do this? What is the point? And what are the dangers? Because that was never
Right.
asked. Nobody ever asked that. And to its great credit, the meeting in 1975, which didn't ask, should we be doing this either? It was just focused on biosecurity. But it did say very clearly, this is what is an acceptable risk. And since it became obvious that CRISPR could be used on to edit human embryos in around about 2015, that question just wasn't asked. Now it is being asked, and the answer is, well, not for very much.
Yeah.
It's not really something that's very interesting. You can
Yeah.
use
So,
it to cure genetic diseases in humans,
right.
but this procedure at best would allow a certain type of human to come into being. It wouldn't cure any disease because the individual who might have the disease didn't exist. And if the two people involved don't have sex, the individual will never exist. Just
Never
like
exists. Yeah.
bazillions of individuals don't exist because people don't have sex.
Every day I make a
Every
choice for
day, think of
humanity.
the infinite number of humans have not been conceived.
Thanks to me. No. Oh, geez. So we're going to be running short on time here
Yeah,
because
I'm sorry, I've been talking too much.
this book is full, and this topic is deep, and it's a fascinating topic because it's about us, right? It really does come down to these questions of who who matters among us. What
Yeah.
do we want to where do we want to go with humanity? And then also, how do we want to impact the world? And along the lines of what CRISPR can potentially do for gene for disease therapies. We're also looking at it and other modification technologies as potential ways for affecting other species on the planet. And I know one
Yeah.
of the topics that you bring up is gene drive, and that's one that we talk about a lot on This Week in Science whenever there are new
Good.
studies. Yeah, because
People need to know about that. Yeah. That's the
people
one
need
I'm most afraid of. That's
yeah,
the one that
people
scares me the
people
most.
need to know about this technology that can lead a gene to just spread uncontrolled within a
Yeah.
population.
I,
When we're
I
talking
think
about
that, yeah.
mosquitoes, it's one thing, but
Well, I mean, even as an insect biologist, I beg to differ. I mean, so I think the first point to make is whenever people talk about, when I talk about gene drives, the first thing I say is 500,000, in fact, that's figures 600,000 people a year die of malaria. The
yes,
vast majority are the children under 5. So if you say we're not going to develop this technology, then that's the price. Okay,
those
that's what you've got to
yeah,
think of.
those
What are
children.
the other solutions? And that's the motivation of the scientists. I've talked to these people, I've interviewed them.
Hmm.
They are all, none of them are crazy. They are all very
No.
concerned by what they're doing, but they're also looking at that other part of the equation, at those 600,000 people. And if you could find a solution to that, then why wouldn't you? Now, the interesting thing
Hmm.
is this very sexy and apparently simple solution, and it is simple, it's complicated, but it's very simple in its consequence of changing mosquitoes or eliminating them from certain regions could have unknown ecological consequences.
Yeah,
And secondly, there may in fact be more simple solutions. So the WHO has just approved a vaccine for malaria, which is only 80% effective, but which is nowhere near as good as our COVID vaccines, but that will be enough to reduce the amount of malaria in the local population and will lead to a massive reduction in transmission. So there may be more traditional solutions. And what's striking is that these gene drives, which, as I say, the scientists are very concerned. The people who either dreamt them up or have actually made them have been terrified. They've
yeah,
said maybe we shouldn't publish this, or one of the Kevin Esfelt is one of the people who's really thought about it hard enough.
yeah.
When he initially, first day, he was really excited. The next day, he woke up and thought, "My God, what this could
What
be."
have I
You know,
done?
yeah. And I didn't tell my
Yeah.
supervisor for a month. He said because he kept it quiet. He was so frightened. So I
Mm.
think I'm not pessimistic or down on scientists, but I want people to know what is being discussed and to think about what the other alternatives might be, and also why we're often attracted to these apparently sexy techno fixes when more fundamental questions and perhaps simpler solutions also need to be addressed. And I don't really have an
Absolutely.
answer to that, but there is a very clear desire for something that is not only effective, but is also elegant and has got a, I mean, you know, I'll be honest with you. That's one reason why I was very happy to get the mRNA vaccine because it's so
Mhm.
sexy. It's so
Yeah.
clever. I didn't want, I
It
didn't want the
works and
boring
it
ones. Give me
no.
that mRNA. It's amazing.
I mean, it really is. We're living in the future, but we are still going to be affecting the future to come. And from your work and research in this book, do we have any history of times when scientists did not just look down on the public, quote unquote, and say, oh, we'll make these decisions. As a scientific community, we're not going to ask if we should. We're just going to ask if we could, right? If we can. Um, and where the public and scientists have come together to actually make decisions about how future technologies will progress. Has that happened?
I you caught me. You got me worried now because it's the kind of question that there must be a yes answer to, but I can't think what it is. I mean, during genetic engineering, there have been a series of public debates and so on, like, as I said, the one in Cambridge, Massachusetts, that have seen these issues thrashed out in a public arena.
Yeah, which they should
And
be.
that's the kind of model, and the end result was the public said, well, this seems as though it's going to be okay, which in fact it was. At the moment, but if you think of the problems, so we're talking here, everybody by definition who's watching or listening has got a computer, they're literate. But if you want to release, say, a gene drive to get rid of malaria in Burkina Faso, as is one of the projects in the long term, there are no immediate plans, you've got to get prior informed consent from the local population. How do you do that when there's no word for gene in the language, never mind gene drive, where the population is illiterate, so what they've done, for example, is to have theatre. They've gone in and they've made plays that can explain to the local villagers what exactly they want to do. But then the villagers, when journalists talk to them, the women say, well, yeah, nobody asked us. We don't have any say in this. And even if your local village did want to let one of these things loose, and you could understand why, because their children are dying, for goodness sake, why should that village decide because the mosquitoes travel
an entire area
or perhaps the whole world,
Yeah.
That's how Zika got into Latin America. It came from Africa. It came over on ships. Mosquitoes are very good at moving about. They lay their eggs in stagnant water, pools of water, old pots on a ship.
Drops of water.
Presto, they end up in where they shouldn't be. So there's a major issue. And we need something like the Civil Aviation Organization, which enables everybody signs up to. There's an international organization kind of vaguely under the UN, which decides what is safe. And pretty much you can fly safely in a civil aeroplane. Or similarly, the International Atomic Energy Authority, which is perhaps more appropriate because it's very dangerous and quite complicated. The question there is, however, do governments now have an appetite for international regulation, especially does the US? I think not. So there are bigger issues behind these scientific issues, and we're getting to big kind of global politics about what kind of world we want to live in.
The science touches all aspects of our lives, and this book is fascinating, and I didn't find it negative as some some reviews said. It's realistic. It's history, and it's a realistic view of where have we been and where are we now, and what do we potentially have on the horizon, and what do we need to be concerned about. And just today, another study came out related to CRISPR. There's T-CRISPR, which is the first gene drive to be used in vertebrates. And
no, I hadn't seen that. I'll check that out.
They're planning to get rid of the house mice in that are invasive to Australia and New Zealand, but it's vertebrate and it has gene drive. And so there are studies.
That's proved intransigent until now. So people have tried and haven't been able to do it. So I'll check that out.
Yeah, brand new workout today.
No, hold the presses. But we need. After that, I've got to add something new.
You have to put that in your book too. And I think this kind of conversation is very apropos to today. It is UNESCO's World Science Day for Peace and Development. And so this topic, this is one that will touch all people. And so as much information as individuals can have, whether or not we consider ourselves as gods, this book is, I think, a great look. And thank you so much for your time today and for speaking.
Thank you very much for inviting me on, Kiki. It's been fantastic.
It's wonderful. Where can people find more information about your book? Follow you online?
I would go to bookshop.org because I don't like the other spaceman.
That's the one, just that one.
Yeah. I think go to bookshop.org or Basic Books, who are my publisher.
Great. And then you have a Twitter account if people would like to follow you.
I am at Matthew Cobb, one word, on Twitter. And I'm on Mastodon now.
It seems as though, the scientific community.
I'm still on both. So
I signed up for Mastodon years ago, and then I was like, wait, nobody's here. And so I stayed on Twitter.
It's very quiet over there. It's very posed, and there's no shouting. It's quite nice.
I like the lack of shouting. Although sometimes you have to shout because you're excited about something.
Absolutely. Yeah, well, there's a bit of that. There's a bit of whooping, but I haven't come across any very grumpy, bad behavior yet.
Not yet. Everyone, thank you so much for joining us for this live interview. Dr. Cobb, thank you for joining me once again. Everyone out there, This Week in Science will be back again next Wednesday at 8 p.m. Pacific time, streaming live on YouTube, Twitch, and Facebook. And we hope you will join us again for more great science news and interviews. And if you learned anything from the show, please remember, it is all in your head.
This Week in Science. This Week in Science. This Week in Science. This Week in Science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth. And I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in 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 Science.